Okay, we're going to take a look at Unit 9, Section 1. We're going to talk about exponential functions today, and they either grow or they decay, meaning they get bigger or they would get smaller. Now, as we are looking here, we have this first one over here. Because this number right here that your exponent is bigger than 1, we would say that that is a growth. Now here, the thing that the exponent's on is also bigger than 1, so we would say it's a growth. Now, here, the thing that the exponent is on, is not bigger than 1. That is a decay. Now, technically, we would have to say it's decay because what the thing that the exponent is on is between 0 and 1. Same idea here. This is between 0 and 1, so that one is also a decay. Now, when you look at these two graphs, we would say the one on the graph on the left, because you go to the right, it gets bigger. We would say that one is a growth graph. Where the one on the right, you go to the right, it gets smaller. We would say that is a decay graph. Now, all exponential functions can be written in this form right here. It's important to note that the thing that the exponent is on, which is b, always has to be between 0 and 1. If it's greater than 1, it's a growth graph. If that is b value right there is between 0 and 1, it's a decay graph. But either way, that b value always has to be positive or larger than 0. Now, this a value right here is where you cross the y-axis, and that comes into play when we are trying to work backwards from a graph to find our equation. So let's go ahead and start the lesson. We're going to go ahead and graph y is equal to 2 to the x. So I'm going to just make a t-chart, an xy chart going from -3 to 4. Now, if I plug in my 4, it would be 2 to the 4th. You multiply 2 times 2 times 2 times 2, and you get 16. Put in 3, it'd be 2 cubed, which is 8. Put in 4, or 2 squared, which would be 4. Plug in 1 to be 2 to the 1st, which doesn't change it. Then, going back to the last quarter, you should remember if you plug in 0, you'd have 2 to the 0. Anything to the 0 power is 1. Now, if you plug in -1, you'd have 2 to the -1. Now, remember that that negative exponent means 1 over 2 to the first power, where this one here would be 2 to the -2, which would be 1 over a 2 to the +2, so that ends up being 1/4. And then if you plug in your -3, that would be a 1 over an 8. So if we just plot these points, 3 to the left, up an 1/8. 2 to the left, up a 1/4. And then 1 to the left, up a 1/2. And then 0 left and right and up 1. 1 to the right, up 2. 2 to the right, up 4. 3 to the right, up 8. And then 4 to the right, up 16. And so then you can go ahead and draw in a nice smooth curve going between all these points. Comes down, goes out here, goes to the left, gets really close to the x-axis but never touches it, and then it curves and goes up. And it's supposed to be a nice smooth curve that looks about like this. Because this is greater than 1, we would say it's a growth since b is greater than 1. You can also see on your graph that it goes up as you go to the right. So now let's take a look at this one here. When we're looking at this one here, once again, we're going to go ahead and make a t-chart again. So I'm going to plug in 0. Then it would be 4 times 1/2 to the 0 power. But remember, 1/2 to the 0 power is 1, so it's a 4 times a 1, so that's 4. Also, remember that when we plot this point, that's 0 left and right, up 4. that we had said this number in front is always your y-intercept, and we can see that when we plug that in. Now, when we plug in this one here, it would be 4 times 1/2 to the first, which would be 4 times 1/2, which is just 2. 1 to the right, up 2. And then when we do this one here, it would be 4 times 1/2 to the second, which, using your calculator, doing it by hand, or doing it online through decimals, doesn't make a difference, you get 1. If we go ahead and try 3, we would get 4 times 1/2 cubed, we get 1/2. And then if we try 4, we get 4 times 1/2 to the 4th power, and we get 1/4. If we try -1, that would be 4 times 1/2 to the -1st, which is, remember that negative exponent flips that fraction upside down, or 2 over 1 to the first then, so it's just 4 times 2 is 8. When we do this one here, it would be 4 times 1/2 to the -2, which is 4 times 2 over 1, because the negative flips it, so it'd be 4 times 4, or 16. If we try -3, we end up getting 32. Now, if I go to 3 to the left and up 32, that's off my graph. So I'm going to just go with this one here, 2 to the left, up 16. Now, if I plot my other green one down here, this one, that's 2 to the right, up 1. And then if I plot my blue ones down here, 3 to the right, up 1/2, and then 4 to the right, up 1/4, then we can go ahead and draw in a nice smooth graph going between all this. And you can see as we come out here to the right, as I'm trying to get it through these points, not always easy to do on a computer, we end up getting this. Now, you should remember from what we talked about that since this is between 0 and 1, it's a decay. And you can see that on your graph as you go to the right. It goes down. So we would say decay because our b value is between 0 and 1. You can't just say less than 1. You have to say between 0 and 1 for a decay. So now we're going to go ahead and try to work backwards, given a graph, come up with the equation. The thing to remember is that when you are dealing with these points, you choose a point like your y-intercept. That always helps you to find your a value. And then you find another point, and then you go from there to find your equation. So first of all, I'm going to choose this right here, which is my point 0, 3. So that means my a is 3. So then I can go ahead and go y is equal to my b to the x, plug in my a value, which is 3. Now I want to choose another nice point. So it's be nice to choose a point that actually goes through a convenient point. I'm going to choose this one here because it looks like it goes through exactly -1 and up 6. Remember, this is x and y, so I can take my 3, don't know my b, plug in my x, which is -1, plug in my y, which is 6, and then I can go ahead and solve this, divide both sides by 3. I get 2 is equal to b to the -1. Remember that that means 1 over b. Multiply both sides by b to get the b out of the bottom. You get 2b is equal to then to 1, and you get b is equal to 1/2. So then we need to rewrite our y is equal to our a, b to the x. Go y equals our a we had said was 3. Our b that we just figured out is 1/2. And then that would be our equation. So here's a follow-up question. So once again, I'm going to choose my y-intercept, which is 2. So that means my a value is 2. And then I'm going to go ahead and choose another point. The point I'm going to choose is this one here. It looks like it's a nice, neat point, which is 1, 6, which means your x is 1, your y is 6. So your y is 6, your x is 1. And then all we have to do is solve it for b. Well, we just have 6 is equal to 2 times b to the first. We solve it for b, divide both sides by 2, we get 3. So then we can just plug everything into our equation. Y is equal to our A, which we knew from our graph is 2, and our B that we figured out was 3. We would say these are exponential equations because our variable, our x, is in the exponent. Our variable, what we're looking for, is in the exponent. Now, on the left side here, we have this as 4 to a power. Now, on the right side, I want to also try to get the same base of 4. So if I write the right side as a 4 to a power 16, we know it's 4 squared. So now, if I have the same base on each side, which I now do, then that means the exponents have to be equal. But we can't say the exponents are equal until we get the same base on each side. So now we have 4 to the power equal 4 to the power, so set our exponents equal to each other. And then all we have to do is just solve this, so we can just add a 1 to both sides. And then we can go ahead and divide both sides by the 3, because that's what's in front of x, and we get 1. Now, looking over here at the right, we can maybe do a factor tree in 32. So we have 2 raised to the 5th power. So our 32 is 2 to the 5th power, still all raised to the negative 3x. Now 64, when we do our factor tree, is 2 times 32. Now we just figured out that this is 2 to the 5th power, and this is another 2 here. Our 64 would be a 2 to the 6th power, still going ahead and raising it to the negative 2. Now, remember, when you have an exponent raised to an exponent, you have 2 to a power. Exponent raised to an exponent right here, you'd have to multiply your exponents. Or over here, exponent raised to an exponent, you have to multiply your exponents. So now that you have 2 to a power equaling 2 to a power, you can just set your exponents equal to each other. And then you can go ahead and solve that for x. So I'm going to go ahead and get all the x's on one side by adding a 15x to both sides. I get 0 is equal to a 3x. Divide both sides by 0, or by 3, and we get x to be 0. Now we're going to do a word problem here. So pause it, read through this. We have a situation where we're starting out with 100 bacteria at 2 o'clock. So 100 bacteria at 2 o'clock. So that's going to tell me my B value is 100. So I have y is equal to, my A value is 100, B to the x. Now we're going to use this. This is the point. Remember, A was 100 at 2 o'clock. So 5 p.m. is just 3 hours later, and we get this. So we're going to have a point to plug in. Once again, we have a 3 here because our 5 p.m. is 3 hours after what we started out with at 2 o'clock. So I can plug in my 800, equaling my 100 times B to the 3rd. Divide both sides by 100, I get 8 is equal to a b cubed. Take the cube rid of both sides, and I get 2. So then I can go ahead and write my equation. Just figured out my b value was 2. We had talked a little bit before how my a value was 100. So that's our equation. Now we can use that equation to help us answer part B down below here. We are wondering what happens at 9 o'clock. Now remember, our 100 was at 2 o'clock, and so 9 is 7 hours after 2 o'clock. So then I'm going to plug in my 7 for my x, And then I can either do that in my head or use a calculator, and I would get 128 with a couple of zeros. So basically 12,800, and then we're dealing with bacteria.